Hi everyone, my name is Shelby Browning and I'm here to talk today about a mouthful of a title, which is a sustainable approach to green pesticide production in Kenya from Croton megalocarpus trees. So first, a little bit about me. I am a junior chemical engineering undergraduate here at the University of Kentucky, and this is actually my 6th year with the University of Kentucky Appropriate Technology and Sustainability Research Team. Yes, it's a mouthful of a title, but props for us for getting cats into it. Because I'm a member of this team, I've had the amazing opportunity to conduct research in Uganda and Kenya, and I've also been the recipient of some various research awards, including the Bucks for Brain Scholarship and the Summer Sustainability Research Fellowship. So, Croton megalocarpus trees are these very, very tall, drought-resistant trees that grow all across sub-Saharan Africa, and they produce an inedible nut that is very rich in oil in its composition, but it's inedible to humans. What we can do with this nut is press it and create a biofuel out of the oil, but this will still leave an organic waste product, which is the husk that surrounds this croton nut. Using a slow pyrolysis process, we have the ability to convert these croton husks into a non-synthetic pesticide called wood vinegar. Wood vinegar is mainly comprised of acetic acid and methanol, and you can see an example image. I actually had a bottle of wood vinegar to bring, but I forgot just how potent the smell was, and I didn't think we wanted to smell like a bonfire today. Another side product from the slow pyrolysis process is biochar, which is very nitrogen rich and can be pulverized and added to the soil as a soil amendment to help retain water and nutrients. So out of this process, you get both fertilizers and pesticides for very agricultural dependent regions. My focus was on collecting percent yield data and composition data on the wood vinegar products. And so throughout the school year, I conducted small scale testing in our lab in Paducah, Kentucky. And I found that higher operating temperatures and increased starting moisture contents give both better percent yields of the wood vinegar and help extract more organic materials from the croton husks themselves. So I took this information that I found with me over to Kenya this summer and worked with a company called Ecofuels Kenya, or EFK, where they are doing this exact same process on a large scale. And here is me next to one of the kilns on their site. So I was there testing the same variables and found that the wood vinegars are pretty much the same in composition, but moving forward, I need to do more analysis on the GC, or gas chromatograph data, which is how we figure out the composition, because while we know the few major peaks, some of the smaller ones are still unidentified, and so I need to test and figure out and become more certain about the composition of the vinegar product. I would also like to start testing this vinegar product as a pesticide in both Kentucky and Kenya on our corn, our soybeans, their flowers, their specialty fruits, and help determine the effectiveness of the vinegar and what concentrations we should dilute it to and how often it needs to be reapplied. Thank you.